this video we're going to be looking at calculating the stationary points of this function given here. So you should recall from a previous video or from looking through the notes, to find stationary points we have to first of all calculate the gradient function, so in this example dy by dx, and set it equal to 0. So dy by dx is equal to 0 at stationary points. So the first thing we need to do then is calculate dy by dx for this example. Now you'll notice here we have two functions. We have x squared plus 1 and the exponential function e to the x, but they're multiplying each other. So that tells us that we should be using the product rule. So if we recall what the product rule tells us, when we differentiate uv, we get du by dx multiplied by v. So differentiate the first term multiplied by the second term, and then we add to that u times dv by dx. So leave the first term alone and multiply by the derivative of the second term. So taking this example, I'm going to set x squared plus 1 equal to u and e to the x as v. So I'm going to set u as x squared plus 1, v is e to the x, and I need to find the derivatives of both of these functions, so I need to find du by dx, which for this example, well, x squared goes to 2x, because we bring the power down the front and take 1 off the power, and we recall that when we differentiate a constant we get 0, so we can say du by dx is just 2x. And to differentiate v, we'll get dv by dx, and if you recall when we differentiate the exponential, it just stays the same, so it's just going to be e to the x. So I can write down now dy by dx for this example, using our product rule, so it's du by dx, so that is 2x, multiplied by v, and then we're going to add to that u, which is our x squared plus 1, multiplied by the derivative of v, so multiplied by e to the x. Before we set this equal to 0 and start trying to solve for x, I'm just going to tidy this up by noticing that there's a common factor of e to the x in both terms. So I'm going to bring that out as a common factor. So if I bring it out from here, it leaves me with a 2x. And if I bring the e to the x out from here, it leaves me with an x squared plus 1. I'm just going to rewrite this bit in the bracket because it's a quadratic, and I like, with quadratics, I like having the squared power first. I'm going to rewrite this as e to the x, and then rewriting this as x squared plus 2x plus 1. Okay, and the only reason I've done that is because it's a quadratic, and we like with quadratics of having the x squared term, then the x term, and then the constant term. So that's dy by dx. We need to set that equal to 0 now to find our stationary points. So if we set this equal to 0, well, two things can happen. We can either have e to the x equal to 0, or we can have the quadratic term equal to 0. Now, if we think about the exponential function, if we do a quick sketch of it, x-axis and a y-axis, if we do a quick sketch of the exponential, it looks something like that. And you can see that the exponential function is never actually equal to 0. It gets very close to it, but it never actually gets there. So when is e to the x equal to 0? Well, it never is. So we don't get a solution from this part. So our only solution comes from solving this quadratic equal to 0. And you should notice that x squared plus 2x plus 1 can be rewritten as x plus 1 squared. So we actually have x plus 1 squared equal to 0. And we can see that the solution to this is going to be x is equal to minus 1. So the stationary point of this solution is at x equal to minus 1. But we need to find the y coordinate. So we have x is minus 1. To get our y coordinate, remember we substitute back into the original function. Okay, so when x is minus 1, y is going to be minus 1 squared plus 1 e to the minus 1. Now, minus 1 squared is 1. So we have 1 plus 1 is 2. So our y coordinate is 2e to the minus 1. Now I'm going to leave this exact. You could type this into your calculator and get an answer to a couple of decimal places, but I'm going to leave it exact. So I can now say the stationary point of this function here is minus 1, 2e to the minus 1. And that there is the stationary point of this function here. Thank you for watching.